And then we had started chapter 3. Nothing from chapter 3 was due yet, correct? Is there any chapter 3 questions at this point? I realize that not everything needs to be done even, but if there were, we can take some time to deal with that stuff.
I'm good.
All right. Well, then the plan for today is we're going to finish the second half of section 3.1. So in the first half of section 3.1, we talked about going from the equation of a function to the graph of its sinusoid. Everybody okay with that? Remember doing that? More or less. What we're going to be doing today is the reverse. So we're going to go from the graph to an equation, or even a information about the graph to its equation. So a couple of things. First off, one of the observations we made last time was when we looked at the graph of the basic sine and basic cosine functions, we noticed that they were essentially the same shape, just translated horizontally by some amount, right? You guys remember noticing that? What that means for us is that any of these problems we're going to be doing could be answered as a cosine function, or it could be answered with a sine function. So they could be done either way. Everybody's okay with that? Additionally, because you could translate, some amount horizontally, and then you could do like that same amount plus 2 pi and end up at the exact same graph, and keep adding 2 pi to that amount you translate, and you're still going to get the same picture. There's infinitely many answers for every one of these. We'll talk about where your choices are along the way, but we're not going to obviously supply infinitely many answers to these. But I just want to put that out there, that there's always a lot of answers, infinitely many in most cases. Okay? All right. So I have 4 examples here that we're going to run through, and then next time in class we'll give you some time to work on some specifics on these, because this tends to be potentially a difficult topic for students to kind of get the hang of. Okay? All right. So what I'm going to be using for starters on a problem like this, where I'm given the graph, this is the easier version of this problem. So we'll see 2 kinds of problems. We'll see some, it's fine, pick up your cap, no big deal. We'll see some where we give you the graph, and some problems where we give you just information about the graph. The graph problems are easier because you have more information. So we can always do things the easiest way possible with the graph. If you're just given information, you don't have as much detail, and sometimes you have to do things the hard way, or have to be a little bit sneakier about what it is you're doing. All right. So let's look at example A here first. So what I'm looking to do, let's do the sine version first, then we'll come back and do the cosine version afterwards. Is everybody okay with that? So that's the general form for the sine function, right? So my goal here is to figure out the values for A, C, H, and K that give me this picture. Cool? If I'm given a picture what I'm going to be using are those attributes that we talked about all of our sinusoids having back in during the last lecture. So I'm going to be using the midline, the period, the amplitude to help me get some of these values. Mr. Kulik likes to start with the midline. If I look at this picture, where's the midline? It's the line y equals 0. Do you remember the general form to find the midline? Was y equals k. So what does that tell me about the value of k in this case?
0.
Has to be 0. Good with that? Okay. Now let's look for the amplitude. In words, what is the amplitude? Okay, the absolute value of A, but like graphically, what is the amplitude? Yeah, Brent? To the midline to an extrema, right? Yeah. To a max or a min. Yes, sure. So that right there would be our amplitude, correct? So remember the absolute value of A is the same as the amplitude. So A then has to be either 2 or -2. We're not sure yet which, but we've narrowed it down. Everybody's okay with that? The next thing I'm going to be looking at is the period. What is the period again? Okay, the formula for the period is 2 pi times the absolute value of c, but visually, what is the period? Braden?
How long it takes before it restarts.
Good. How long it takes before the graph restarts itself. So that is, in our case, oh boy, little boise, the whole thing, right? Or if I start here, I have an up, and then I have a down, and then I'd be starting the up again. So I know one period is equal to, well, if I read my axes, this spot over here must be -2 pi, and this spot over here must be +2 pi. So how long was that? 4 pi. Everybody cool? So we knew the period is 2 pi times the absolute value of c. So I know the absolute value of c then is 2. So c equals 2 or -2. Everybody's okay with that? All right. So now it's time to make some choices here. So choice number 1, bless you. Notice if I have the graph of sine and I reflect it, I get that, right? But that would be the same thing as if I had like shifted the blue over, I could get the same result. Everybody agree with that? If I just took the blue graph and I shifted it left or right, I could end up with the same thing as the reflection. Everybody's agree? Okay. So what that's telling me is that I can really choose to either take the negative on A or C or the positive on A or C and just make up the rest with the reflection or with the translation piece. Is everybody okay with that notion? This is the way that I like to do it. I like to always pick the C to be positive And then I'll make up the A and the H so that they match up. Everybody's okay with that? All right. So the last thing I need to do is figure out whether A should be positive or negative. And then I need the value for H. So to do that, what I'm going to be using is my map that I used when I graph that transforms parent function into resultant function. Okay with that? What I'm going to do is I'm going to look at my points on my parent function for sine. I'm going to pick one of these to use. Of those 5 points there, which one appears to be the nicest one? 0, 0 should hopefully be the one you want to pick because it makes everything, will make everything simplest. Now, when I look at the graph of sine, what type of point is 0, 0? That's a midline point, right? That's a point that lies on the midline. But there's actually 2 different kinds of midline points. Notice that this is a midline point that precedes a maximum and is preceded by a minimum. You guys kind of see that? We have a minimum, the midline point, and a maximum. The notation I'm going to use that is a down, midline, up. If I had instead chosen this point here, notice that this point, also a midline point, but it's preceded by a maximum and then followed by a minimum, that there are 2 different kinds of midline points. Everybody can see that? So I'm just going to make a note that 0, 0 is that kind of midline point. Now I'm going to go to my graph. I'm going to pick one of the midline points on my graph. I could pick this midline point, this midline point, or this midline point. It doesn't really matter. Which one would you choose? I'd pick 0, 0. But in addition to knowing that's a midline point, I also want to know what kind of midline point it is. So here we are preceded by a maximum and followed by a minimum. So my first observation is I notice that these are opposite. Everybody see that? They're the different types of midline points. Well, what that tells me is that the A needs to be negative. So we're going to take the -2 for A. Everybody's okay with that? This information is also going to tell me how to get the H. I know that CX plus H has to give me 0. And what is the X here? It's the X from the parent function. Everybody's okay with that? So I know C times 0 plus H has to equal 0, or H is just 0. Now we have everything we need. What is going on? So that is one possible answer. Where would have different answers come in? Had you used like a different kind of point instead of a midline point, used a different midline point with 0, 0, or used a different midline point than 0, 0, all of those things would have given you like slightly different answers. Although they would have all been the same picture. So how you make your choice there could dictate different answers. I would encourage you always to try to do it the easiest way possible, which means if you can pick something where there's a 0 in the x coordinate, that's the best choice. All right, let's do the cosine version. Get rid of that out of there. So everything that we've done up into that point, finding the possible values for A, C, and K, all that is fine. So we still know that A is plus or minus 2. We've decided C is going to be 2. We know K has to be 0. The only things that are going to be potentially different are the values for H and A. Everybody's okay with that? So everything we had done before that point would have still been the same process, whether we're doing a cosine graph or a sine graph. Everything that we did up here all still counted for doing cosine. None of that would have been different. So I'm not going to redo any of that. I'm just going to leave it there. Is everybody okay with what I mean? So just like for sine now, I'm going to be using this transformation map. So I'm going to go to my parent function and pick a point from that parent function to use. So I'm going to be looking at the cosine points. Which of these cosine points looks the most appealing? 0, 1. I like that because the x coordinate is 0, and I'm looking for h, which has to do with the x's. On the graph of cosine, what kind of point is 0, 1? It's an extrema, right? Specifically, what kind of extrema? Maximum. So, what I can do now is I can go to my graph and I can pick any extrema to pair with cosine. So I could pick this maximum at negative pi comma 2, or this maximum at positive pi comma negative 2. Doesn't matter which one. Which one would you like to pick? Let's pick negative pi comma 2 because it was the first one as we read the graph from left to right. For no other better reason than that. Everybody's okay with that? Now, what type of extrema was negative pi comma 2? Maximum. So I notice that here I'm mapping the same type of extrema. That tells me that my A needs to be positive. So here, the A I'd pick would be positive 2. Everybody's good with that? And then just like I did for sine, I know that Cx plus h has to equal negative pi. And what is the x here? It's the x from the parent function. So I know c times 0 plus h has to equal negative pi, or just that h is negative pi. That's everything I need. So that's a potential answer. Katie. That's the parent function. This is the parent function. This is just y equals cosine x. I was just using that as to demonstrate you what kind of 0.01 was. Is that okay? So that wasn't the picture that we had above, shifted. That was just the parent. Well, I mean, the parent function is the picture above transformed, but like that's why that picture is there. Is that okay? What do you guys think? Have you noticed a pattern here? That if I'm picking the parent function to have an x-coordinate of 0, the point that I'm pairing it up, the x-coordinate is just my value for h. That we really don't need this step in here at all, because c is just always zeroing out. So just you're left with h as that x-coordinate. Braden? Sure. Let's do the other example of graph, or the other example graph. So we'll start the same way. We'll do the sine one and the cosine one both, just to let you get a feel. Unless the directions are asking for both, one or the other would be appropriate. You don't have to give both. But I'm going to do these both ways for us, just to make sure that we kind of get a feel for what's going on. Everybody's cool? Okay. So how did we start? First thing we look for is midline. Where's the midline at? Looks like y equals 1. And what does that tell us then? Gives us our value for k right away. Sounds so good so far? What's the next thing we look for? Then we look for the amplitude. Actually, just do it all in red. So that gives us the two possible values for A. You okay there? Last thing we're going to do is look for our period. So if I count from max to max, that's going to be a period, right? How far did that go? pi units long. So I know then that c was 1/2 or -1/2. Everybody okay so far so good? You'll stop me if you have questions, right? Am I going at an appropriate pace? This is okay? Okay. So we're always just going to pick the c to be positive. We have our value for k, so we need to know now whether a is plus or minus, and we need the value for h. To find these, we're going to use our transformation map. What point do you want to pick from the parent function to use? 0, 0, because it's sine. Remember, 0, 0 was the midline point that went minimum, midline point, maximum. What we'll do now is we'll go to our graph and we'll pick any midline point from our graph. So any of these midline points would be okay. I'm going to say pick this one just for grins. Everybody okay with that? Note that this is the midline point pi over 4, 1. And that goes maximum to the midline to minimum. Is everybody okay there? So if I compare the two midline points, what does that tell me about A? A has to be negative. And then if I look at the x coordinates, what does that tell me about the h? Since the x coordinate from the parent function is 0, the x coordinate from the resultant function is just going to be my h. And I'm done. Now, for the record here, I haven't been simplifying any of my expressions or my final answers. You can simplify yours, like it's fine to do that. I'm just haven't been doing it because we're writing notes. And I want to make it really clear if you go back and look at these, like where the numbers came from. You know what I mean? But you could certainly just write that as negative sine 2x minus or plus pi over 2 plus 1, right? Like everything is distributed through and simplified and da, 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 da. So you don't have a trillion parentheses rattling around in there. That's okay. So if I were doing the cosine, same process. So we need to figure out whether the a is positive or negative, and then the value for h. What point from the parent function would I be taking? Since we're doing cosine, using 0, 1, which was a maximum. And I'm going to map that to any extrema from my function Which one do you suppose Mr. Kulik would pick? Boy, I like that one quite a bit, right? 0, 2. Note that that is also a maximum. So this tells me, since they're both maximums, that tells me the A is positive. And then since the x-coordinate on my parent function is 0, the x-coordinate from my resultant function is my value for h. So h is 0. And that's all I need. How are we doing with this? Is this okay? I try to make it as visually as I can. All right. Let's go and do one of these examples. All right, so here it's a little bit more difficult because instead of given the whole graph, we're just given a little bit of information about the graph. So we're told that we have an amplitude of 4. What is that going to tell me? Good. So the amplitude of 4 tells me that A is either 4 or negative 4. Everybody agree with that? Okay, we have a period of 3 pi. What does that tell me? Okay, I can use that to figure out C. So remember the period is 2 pi times the absolute value of C. So when I divide both sides by 2 pi, C is 3 over 2 or negative 3 over 2. Everybody's okay with that? All right, and lastly it says, then the graph passes through the point 3, 1. What? Well, that has to tell me what information does that have to tell me? And H. I have to be able to get both those pieces of information from that. Does everybody agree with me? Here's the lovely part about this. Does it tell me what kind of point 3, 1 needs to be? No. So I can have 3, 1 occur wherever I want. Like if this is 3, 1, it could be a maximum. It could be a midline point. It could be a minimum. Anywhere I want to make, any place I want to make that, I can make it. Because it doesn't specify where that 0.31 needs to occur on my sinusoid. Right? Whether it has to be a midline point or a maximum or minimum or something else. Doesn't tell me. So I have the freedom to choose. Everybody cool with that notion? All right. So we're going to fix the C to be positive just like we always do. Let's say we're doing sine. What point from the parent function do I want to use? 0, 0. And I want to map that up with 3, 1. So remember that 0, 0 is that kind of midline point. I get to pick what kind of midline point 3, 1 wants to be. Well, like Why wouldn't I do that, right? So that's going to tell me the A is 4. And since the x-coordinate here is 0 in the parent function point, what's that telling me about the value for h? It's 3. And since the y-coordinate is 0 from the parent function, what does that tell me about the value for k? It has to be 1. So there's everything I need. Mr. Kulik, that really wasn't so bad. No, this is the easiest version of an information about the graph problem. Now, let's imagine that we had used cosine instead. What point from the parent function do we want to choose if we're using cosine? 0, 1. Remember, that's a maximum. So that'll go to 3, 1. Where should we put 3, 1 then? Has to be a type of extrema. I'm going to pick it to be a maximum. So what does that tell me about A? Has to be 4. Since the x-coordinate of my parent function is 0, the h has to be the x-coordinate from my transformed function. However, look at the x-coordinate from my, or the y-coordinate from my parent function. It's not 1, it's not 0, is it? So I have to actually solve an equation there. So I'm going to have ay plus k has to equal 1. Well, let's do this. How about that? Does that help if I write it that way? That's probably helpful to put it that way in the formula. I'm telling you where the y's are coming from. Yeah, that's probably a better, smarter way of notating that. So when I solve for that, I get k equals -3. We feel okay on that? Now, if you had your choice, which one of those was easier to deal with? The sine one, right? If you're not told which one to do, like, I'd pick a sine because finding the k was just a little bit easier. We basically got it for free. You know what I mean? Okay. This will be our last example, then I'll give you some time to work on problems. So here it says construct a sinusoid that has a minimum value of 510 and its next maximum is at 1532. Well, I would suggest here starting by drawing a picture. So we have that much of the graph, right? Everybody agree with that? Okay. So if I were to draw the midline here, it would come through like here-ish, right? You guys agree? So that's literally the middle between 10 and 32. You guys agree with that? So how far is that? It's 11 units up, right? To the middle, and then another 11 units up to the top. You guys see that? So what did I just figure out there? Yeah, the amplitude is 11. And then the K is 21. Okay. Now I like doing this visually. How would you do this algebraically? You could say K is the midpoint between the Y max and the Y min. And the amplitude then is going to be half the distance between the Y max and Y min. Everybody's okay with that? So you could do that too. That's okay. You can think about it with formulas if you prefer. I like drawing the picture because I think intuition, I'm less likely to get confused which one is the addition one and which one is the subtraction one. I might screw that up without thinking about it, but if I draw the picture, I feel like I'm not going to screw that up. But whatever you feel more confident with is fine. Okay, so we still need to figure out the C somehow, right? That's something that I'm not going to be able to get algebraically or using that function map. So if I'm going from here to here, how much of a period do I cover? Right, if I was to complete one full period, I would draw that much, right? How much of a period do I have in the solid? Just use your eyeballs. Looks like half. Everybody agree? Okay. And so how far is that horizontally? Well, just the absolute value of x max minus x min. So 15 minus 5 is 10. So one period then is how far? 20. And I know that one period is 2 pi times the absolute value of c. So c is 10 over pi or negative 10 over pi. So far, so good. Remember, we're always going to pick the c to be positive. Now, everything else from here will depend on whether we want to be doing a sine graph or a cosine graph. Which one is going to be the easier one to do? Not sine. You want to do a cosine here if you're given a choice. Why cosine here? What kind of points are you given? You're given extrema in the problem, right? Those are the only points you know about. What's the easiest point to use in cosine? A maximum at 0, 1. I don't want to use pi over 2, 1 from sine to match up with that. Yuck. I mean, I can do it, but do I have to, Mr. Kulik? Only if you choose to do it that way. So I would do cosine here, would be my preference. We'll do it as sine also so you can see the difference. So I'm going to pick 0, 1, which was my maximum. And I'm going to match that up with the maximum that I'm given. Since these are both maxima, what can I say about A? It's positive. And since the x-coordinate for my parent function is 0, I can say that the x-coordinate for my resultant function is h. And there's everything that I need. Now, if we had chosen sine instead, it's not much more difficult, but it's a little bit. So for sine, I need to pick one of the extrema because that's the type of point that I'm given in the problem, is I only know about maxes and mins. So I have to use a max or min from the parent function. None of those are 0, Mr. Kulik. I know, that's why I wanted to use cosine. Let's just, for the sake of argument, say we pick pi over 2, 1, just because it's the first one. So that matches max to max. That will tell me that the A needs to be positive. But to get the H, oh no. I have to do C times the X from the parent plus H has to equal the X from the resultant. So I get that H is 10. So not a lot more work, but like, I don't have to do it if I don't choose to do it. Unless the directions specifically call for me to give both, which is not the norm. You know, like, why would I do it? What do you guys think? It's okay? All right. So for this lesson, you guys should be able to do problems 7 and 8, and then 13 and 14. And then you guys should be able to do worksheet 3. And also worksheet 2. I would do them in this order though. Worksheet 3 I think is easier than worksheet 2. So I would do them in that order. So this will be the first assignment for next Sunday's homework check. And we'll take some time in class next time to let you guys continue working on these worksheets. because specifically worksheet 2, by the end of it, there's some tricky stuff that happens in there that you probably need a minute to kind of work through and talk to your friend and talk to me and kind of work your way through it to kind of see what's going on. Okay. The nice part of the way I've tried to present this to you is that all the problems can kind of be done the same way. You don't have to do anything different. It's just like visualize what you have and pull the information from it. But let's stop here.